Hello, today I'm going to be teaching you about how you can bring magic to the real world, actual magic to the real world. First, I wanted to go over something with you. In order to bring magic to the real world, you would need something like a charged particle beam. So I wanted to go over what a charged particle beam is with you. Okay, charged particle beam. A charged particle beam is a spatially localized group of electrically charged particles that have approximately the same position, kinetic energy, resulting in the same velocity and direction. The kinetic energies of the particles are much larger than the energies of particles at ambient temperature. The high energy and directionality of charged particle beams make them useful for many applications in particle physics. See particle beam applications and electron beam technology. Such beams can be split into two main classes. Number 1, unbunched beams, coasting beams, or DC beams, which have no longitudinal substructure in the direction of beam motion. Number 2, bunch beams, in which the particles are distributed into pulses, bunches of particles. Bunch beams are most common in modern facilities since the most modern particle accelerators require bunch beams for acceleration. Assuming a normal distribution of particle positions and impulses, a charged particle beam, or a bunch of the beam, is characterized by the species of particle, e.g. electrons, protons, or atomic nuclei, the mean energy of the particles, often expressed in electron volts, typically keV to GeV, the average particle current, often expressed in amperes, the particle beam size, often using the so-called B function, the beam emittance, a measure of the area occupied by the beam in one of several phase spaces. These parameters can be expressed in various ways. For example, the current and beam size can be combined into the current density, and the current and energy or beam voltage V can be combined into the perveyance, K equals I multiplied by V to the negative 3/2 power. The charged particle beams that can be manipulated in particle accelerators can be subdivided into electron beams, ion beams, and proton beams. Common types: electron beam or cathode ray, such as in a scanning electron microscope, or in accelerators such as the Large Electron Positron Collider or synchrotron light sources. Proton beam, such as the beams used in proton therapy at colliders such as the Tevatron and the Large Hadron Collider, or for proton beam writing in lithography. Ion beams, such as at the Relativistic Heavy Ion Collider or the under construction facility for rare isotope beams.